Hello, our last video about descriptive statistics is all about percentile graphs. A percentile divides a distribution into 100 equal groups symbolized by P1, P2, P3, P, and then all the way to N. The nth percentile, or Pn, is the value such that n% of the data is less than n, which is a very mathy way of saying, it's a way of saying how much bigger you are. So a lot of times you hear about this when you talk about like growth of like children over the course of time or that kind of stuff. So if you say you're in the 40th, you say you're in the 40th percentile for height or weight or whatever. That means that you are bigger than 40% of the other numbers in the data or the other people in the data. That means you are also less than 60%. So how do we do this? How do we calculate this? So here we have some categories. We have some boundaries of classes, and then we have the frequency of the times that they occur. So if we're going to create a percentile, first we have to figure out how many total items we actually have. So we're looking at our frequency, and we're just going to add up that column. So we have 11. We have 11 plus 15 plus 15 plus 12 plus 7, which is 60, which is a nice number to work with. So when we make our percentiles, or we're trying to determine our percentiles, a person who is in this first boundary, 58.5 to 61.5, we have to calculate what percent out of the whole set of numbers they're in. So it would be 11 out of 60. And we're gonna just divide 11 by 60, and then you move the decimal place 2 spots. So we're looking at 18.3%. So then, this percentile would be 18.3%. Then the next one goes from 61.5 to 64.5. So we want to know how much would the 64.5% be bigger than? What percent of the data? So first we have to add these two. So we have 11 plus 15, which is 27. So it would be 27 out of 60. Which is 45%. So then the next range of numbers, 64.5 to 67.5, we're going to take the 11 plus 15 plus 15 again. So that gives us 41. And then 41 divided by 60 is going to be 68.3%. So a person in this data set is bigger than 68.3% of the people in the study. Then you repeat the process, 67.5 to 70.5, this range. So we're doing, I'm kind of running out of space, 11 plus 15 plus 15 plus 12. Which is 53 out of 60, which is going to give you 88.3. So a person in that range of numbers is greater than 88.3% of the people in the study. And then the last one, when you add them all up, you have 70.5 to 73.5. This, you end up getting 60 out of 60. So that's your 100th percentile. So when you plot this, a lot of times you can make a graph out of it to kind of see where people fall or things fall or whatever. So you're really looking at this number in the range, the 61.5 and the 64.5 and the 67 and the 70. That's kind of the number that you're thinking about because this person is bigger than 18.3% of people in the study. Not necessarily this person. We don't have specifics on those people. So we can kind of stick a break in the graph here and we plot the 61.5. So 61.5, and then we'll stick a break in the graph here and say like 18. That's about right there. And then my next one, the next thing I'm thinking about is 64.5, 61, 62, 63, 4. And then they're at 45%. Maybe we should have been a little bit more exact here and said that this was maybe like 20. We'll go up by 5s. So this person is going to land right there. Then our next person we're thinking about is 67.5, 64, 65, 66, 67. This 67.5 person is bigger than 68.3. So 50, 60, 70. So we're looking at right about there. We're definitely kind of running out of space now. 80, 90, 100. When you make these yourself, you can make them a little bit nicer. So now we're looking at the 70 person. 67, 68, 69, 70. And they're going all the way up here to, they're bigger than 88.3%. So that's about right there. And then you're 73.5, 70, 71, 72, 73. That's going all the way up here to 100%. So this graph is kind of looking like this. Again, a lot of it all just depends on your data. There really isn't a necessary shape that we're looking for in this situation. This is our last video about probability distributions, or sorry, about descriptive statistics. Feel free to ask me any questions, and as always, make good choices.